Exercise 4.4 question number 13. We have to integrate x raised to power 4 divided by x raised to power 4 plus 2x square plus 1. Since both the numerator and the denominator has highest power, same highest power, so this is an improper fraction, so convert it into the proper by dividing it. And we know that how we can divide this function. Just write the numerator inside and write the denominator outside like this. Now we know that x4 when divided with x4 will get here 1. Multiply this 1 with this whole equation, will get x4 plus 2x square plus 1 here. Now change the signs because we need to subtract it. We'll get minus 2x square minus 1. Now the method of writing it in the fraction form is 1 plus 1 plus this whole thing as the numerator divided by this denominator. Now move this, since we have here negative sign with both of them, so just take it common. All the signs will become positive here. So we got 1 minus 2x square plus 1 divided by x square plus 1 whole square. This is our equation number A. Now we need to simplify this because we know that if we take the integration of 1, that will be x. But we don't know the integration of this function. So just separately consider this fraction and have the partial, find the partial fraction of this fraction. After finding the partial fraction of this fraction, just use its value here in equation A and then integrate the both sides. So consider this fraction for now. Now we know that 2x square plus 1 divided by x square plus 1 whole square. Since we cannot further simplify this x square term, so from the start we need to write it like ax plus b divided by this whole thing with power 1, then cx plus d divided by this whole thing with highest power 2. This is our equation number 1. Multiply both sides with this whole denominator. I will get 2x square plus 1 equals to ax plus b multiplied by x square plus 1 plus cx plus d into 1 here. Now simply just open this thing. Ax will be multiplied with this whole bracket and b will be multiplied with the whole bracket like this. And cx plus d are written as it is. Mark it as equation number 2. Now we don't have any simplified x value here so that we can let it equals to 0. So just now we have to compare the coefficients. So starting from the highest coefficient. Comparing coefficients of x cube, we don't have any coefficient of x cube here, so I write 0. Coefficient of x cube here is a, so a is equals to 0. Comparing the coefficients of x square, here left hand side we have 2. Here we don't have x square coefficient. This is the x square coefficient, that is b. So we get b is equals to 2 here. Now comparing the coefficient of x, we don't have x value here. We have here x, that is a. So write a here. 0 is equals to a and plus c. Put the value of a, we'll get the value of c here. Now comparing the constant terms, here we have a constant term 1, constant term plus b and plus d. So we got 1 is equals to b plus d. Put the value of b here, we will get d is equals to minus 1. Now putting all these value of a, b, c and d in equation number 1, we will get this thing. 0 into x, that is simply we will remain with 2 over x square plus 1 and here we will get minus 1 over x square plus 1 whole square. Now this is the partial fraction of this term and we know that this term was here in equation number a. So just use this term value in equation number a, we'll get this whole thing. In place of just, we get left hand side is equals to 1 minus this whole partial fraction term. So left hand side equals to 1 minus this whole partial fraction term. Due to negative sign, I have just draw the brackets here. Open the brackets, multiply the minus sign inside, we'll get this equation. Minus 2 over this thing, minus minus plus over this thing. Now use the integration on both sides. We'll get here 1 dx minus 2, 1 over x square plus 1 dx plus integration 1 over x square plus 1 whole square dx now. Integration of dx is x, integration of 1 over x square plus 1 is tangent inverse of x. Now we don't know the integration of this function. For that purpose, consider it separately because it is not simply, we cannot simply find it out here. It will be mixed up with these two answers. So just take this separately. Just find its integration separately and then put back the value here in b equation. Consider this integral. Let x is equals to tangent theta, dx equals to secant square of theta d theta using the substitution method. Replace the values. Dx will be secant square of theta d theta. X square is tangent square of theta plus 1. 1 plus tangent square of theta is secant square of theta. This is an identity. Secant square of theta whole square will be secant 4 of theta. So the secant 4 of theta after cancellation with the numerator will give us 1 over secant square of theta. And 1 over secant square of theta will give us cos square of theta d theta. We know that we don't have any formula for integration of cos square of theta. Just split it into the half angle identities, that is 1 plus cos 2 theta over 2 d theta. Now separately, this integration can be separately written with this function and with this function. It will be written as half of integration d theta plus half of integration of cos 2 theta d theta. It is written separately now. This integration will give us theta. We know that cos 2 theta integration is sine 2 theta over 2. 2 and 2 will become 4. Sine 2 theta. This is an identity and it is equals to 2 sine of theta cos of theta. 2 and 4 will be cancelled and we get 1 by 2 sine of theta cos of theta. Our question was not in theta. Our question was in x terms. So just replace back the values of theta. What we left in the start, x is equals to tangent theta. So that the value of the theta will be tangent inverse of x. Now we know that 1 plus tangent square of x is equals to secant square of theta. So secant of theta will be under root 1 plus tangent square of theta, and tangent theta is x, so it will be 1 plus x square under root. So we know that secant theta, the value of secant theta, if we take its reciprocal, we get the value of cos theta, that is 1 over 1 plus x square. Now using the other identity, that is cos square theta plus sine square theta is equals to 1, using that identity we can get the value of sine theta as this. Put the value of cos theta, sine theta and theta in this equation one by one. We'll get its answer as half tangent inverse of x plus x over 2 into 1 plus x square plus c. Now this was the answer of this integration. So put it back in equation b. We will get the first two. Now put this whole answer in equation number b. We'll get the first two things were the same as the previous one. Only the last thing is replaced with this answer. Now we know that tangent inverse of x, tangent inverse of x. So both are same. So functions are same. So their coefficients can be simplified. It can be simplified as 1 by 2 minus 2, that is minus 3 by 2. Tangent inverse of x plus x over 2 into 1 plus x square plus c. Question number 14. Integration of x square plus 1 divided by x4 minus x square plus 1. We can just take common x square outside of this denominator. After taking x square common, here will be left behind x square minus 1 plus 1 over x square. We can move this x square, this denominator below this numerator, as x square plus 1 over x square. This is the same thing as the previous step. Now after dividing it with first term and then dividing it with the second term, we'll get 1 plus 1 over x square dx divided by x square plus 1 over x square minus 1. Now let x minus 1 over x is equals to t. Taking derivative on both sides, we'll get 1 plus 1 over x square dx equals to dt. Now 1 plus 1 over x square dx is replaced by dt. X square plus 1 over x square, but here we have x minus 1 over x. If we take square on both sides, I will get x square plus 1 over x square minus 2 equals to t square. That will be equals to x square plus 1 over x square is equals to t square plus 2. So just replace x square plus 1 over x square with t square plus 2 like this and minus 1 as it is. After opening this bracket, I will simplify it as t square plus 1. And we know that its integration is tangent inverse of t. Substitute back the value of t, that is x minus 1 over x, that is we'll get tangent inverse x minus 1 over x. that can also be written as tangent inverse x square minus 1 over x and plus constant of integration. Question number 15. Integrate 1 over e raised to power x minus 1 whole square. Let e raised to power x equals to t. We know that we cannot simply just simplify it using the partial fractions, because for the polynomials the partial fraction is easy, but for these exponential type of functions we don't have a practice for the partial fraction question. So just simplify it first. Let e raised to power x is equals to t. Take the derivative on both sides. We will get ex dx is equals to dt. So dx will be dt over t. Substitute the values. Dx is dt over dt and e raised to power x is t minus 1 whole square. Now this thing will be 1 over t into t minus 1 whole square. Now we can simply find its partial fraction. That will be a over t plus b over t minus 1 plus c over t minus 1 whole square. Multiply the whole denominator on both sides. We'll get this equation number 3. After simplifying, opening this formula and multiplying this t inside, we'll get this whole thing. Now put t is equals to 0 because we have t here. We can let t is equals to 0. Put in this equation number 3. We'll get 1 is equals to a into 0 minus 1 whole square, because this whole thing will become 0 and this thing will be 0 due to the presence of t. We'll get a is equals to 1. Now let t minus 1 equals to 0 and get t is equals to 1 in equation number 3 and get the value of c here. Now we need another constant. We just have the value of a and c right now, but we don't have the value of b. So for that purpose, need to compare the coefficients. Comparing the coefficient of t square from equation number 4, we'll get 0 plus a plus b. After putting the value of a here, we'll get the value of b, that is minus 1. Now using the values of a, b and c in equation number 2, we will get this equation. Now this is the partial fraction of this thing and that was included in equation number 1 here. So just put the value of this equation, whole partial fraction, in equation number 1, we'll get this term. Now just divide this integral into 3 parts and integrate it. The integration of 1 over t will be ln t. Integration of 1 over t minus 1 will be ln t minus 1. And the integration of 1 over t minus 1 whole square is that thing. This function will be moved in the numerator like this, t minus 1 minus 2. Now power plus 1 divided by that power, that will be simplified as this, minus 1 over t minus 1 plus c. Now our question was in e raised to power x. What we were supposed in the start? We supposed in the start that e raised to power x is equals to t. So just replace back the values of t here as e raised to power x. So this is our answer of this question number 15.